the senses. Hearing. This is the ear. The external ear consists of basically what you see on the outside. The external ear goes to just before the eardrum or the tympanic membrane. The auricle or pinna is the outer portion of the ear that you see here. So the flap that is on the outside is the auricle or the pinna. The pinna collects the sound waves and directs them towards the tympanic membrane. The external auditory meatus, it's also called the external acoustic meatus, is basically the fancy name for the ear canal. This here is the external auditory meatus. It's simply the tunnel that leads towards the tympanic membrane. Now we're looking at the middle ear. The middle ear is this portion here. The middle ear contains the ossicles. The ossicles are the smallest bones in the body. They are what vibrate to send the sound waves to the nerve center that will turn the sound waves into nerve impulse. In the middle ear, or beginning in the middle ear, we have the tympanic membrane. The tympanic membrane is the eardrum, and that is located right here. This is what the eardrum looks like from looking through the auricle. This is using an otoscope to look at the membrane. It is a very thin membrane, and it vibrates in response to sound waves. On the back side of the tympanic membrane are the ossicles, and you can kind of see them through the tympanic membrane a little bit here. When the doctor looks in your ear, what they're looking for is to see if there is any changes or swelling in this tympanic membrane, or if it's bulging, and this would be indicative of an ear infection. Let's take a look at the ossicles. The ossicles are those three little bones that are found in the middle ear. They are the smallest bones in the body. We have the malleus. This is also known as the hammer. And just so you know, I will not accept hammer, anvil, and stirrup on the test. You need to use the true anatomical terms of malleus, incus, and stapes. Malleus is the first of these bones. It is right here. It is the one that connects directly to the tympanic membrane. The sound waves travel from the tympanic membrane vibrates, and then vibrates the malleus. This is a picture of the malleus up close. Then we have the incus. The incus is the middle of the bones. It is here. When the malleus vibrates, it will then vibrate the incus. Here is the incus up close. And then we have the stapes. The stapes is the third of the ossicles here. The stapes connects to the incus and transmits that vibration from the incus to the cochlea, and the cochlea is where we turn those vibrations into a nerve signal. Here is the stapes up close. We have the auditory tube. The auditory tube is also known as the eustachian tube. The auditory tube is this tube here. This tube connects to your nose, and it helps equalize pressure on both sides of the eardrum. When you open your mouth wide and you hear that clicking noise, what you're doing is you're equalizing the pressure. And so when you have your sinuses full of mucus, oftentimes there can be pressure on the backside of the tympanic membrane and putting pressure here, and it feels like you need to pop your ears. When you are a child, the position of the eustachian tube is much different than an adult. As a child, the eustachian tube is much more horizontal, and as you grow and become an adult, the eustachian tube becomes more upright. Now, this can cause problems in children as when the tube is horizontal, it will hold infection a lot more easily than when it is more upright. And ear infections can be more common. If you've ever heard of anyone that has tubes in their ears, what the tubes are is that the eustachian tube is not necessarily staying open and pressure can't equalize on both sides of the membrane, and a small piece of tubing is placed into the eustachian tube in order to keep it that open. And now onto the inner ear. The inner ear is here. The inner ear contains the labyrinth. The labyrinth is this very complex set of tubules, and it is called a labyrinth because it is it looks quite like a maze. As a part of the labyrinth, we have two parts. We have the cochlea. The cochlea is here. The cochlea kind of looks like a snail. This is the center for hearing. So the vibrations that the tympanic membrane pick up, that sends to the malleus, that sends to the incus, that sends to the stapes, is now going to be sent to the cochlea. The cochlea contains specialized cells that will vibrate a fluid inside in that cochlea, and that then translates into a nerve impulse. The organ of Corti is the organ inside the cochlea that changes those sound waves into a nerve impulse. There are small little hairs. This is a cross-section of the cochlea, and this is basically looking at the inside of the cochlea. There's going to be small little hairs on the inside of this organ. They are little hairs on the ends of cells, and they vibrate from the passing through the ossicles. And then there's a fluid that is inside here that vibrates, and as this fluid vibrates, these nerve cells pick up that vibration and then will send that vibration in a form of a nerve impulse to the brain in order to be then translated and figured out what that sound is. These semicircular canals are your organ for balance. There is a liquid inside the semicircular canals that, as your body or head moves back and forth, it allows the brain to figure out if you're upright or upside down, and then can be translated from there. Static equilibrium is what keeps you upright. Static means kind of standing still. When we are looking at the cells inside that semicircular canal, these little hair cells are standing upright, and there are these little particles here that will move in the face of gravity. Dynamic equilibrium is going to be looking at movement. When your head moves, these particles move, causing those little cells to bend, and then your body will know that you are in movement and you're no longer upright. And then your body can respond from there. And that is the sense of hearing.